Let me know when you can see the slide deck.
Yeah, it's visible.
Okay, great. So hi everyone. So today we'll be talking about, I decided to pick up this topic, sharding. I don't know how many of you are new to this session. I see quite a few folks joining in today. So just to bring everyone on same page. So this is a kind of a supporting session we started along with the book club for designing data intensive applications. And so usually that book club is run on every Saturday where we go over the chapters of, this book, designing data intensive applications. And this session, we started hoping that we could cover some of the concepts that we are learning from that book, the fundamentals, and see how they are applied in the real world. So that's kind of the theme for this Wednesday session. And Yeah, I mean, it's just been about 5, 6 sessions so far. So depending on the participation, we can see how far we go with it. Um, that being said, so let's get started. So today what I thought of covering was, so I'm putting here like 4 different articles that I came across. Sorry, question. All right, so yeah, so the recordings are available on the YouTube channel for SDE Skills. And if we have any other questions, feel free to, just speak up. I won't be able to monitor the chat. Um, Yeah. So these are the 4 articles that I read through for this session today. And the first 3, like the top 2 and this one here, third one, let me use the pointer. Yeah. So the first 2 and this one are all related to Azure. And this one was brought up recently. I don't know, I'm not sure about the name, but someone brought this article by Facebook on sharding and how they have actually set up a generic sharding platform, which supports many of the services in the Facebook ecosystem, right? So it's a pretty interesting article, and some of the concepts that they talk about, I could see them even talked about here in Azure. So that was a good, overlap there. And I could see how some of these concepts are applied widely across different applications. Um, this one here, this article, the second one, it was very interesting as I picked up because, I mean, my idea of picking that up was that you see the index here, right? It talks about, I was hoping that it will give me a very, good picture about how partitioning and how sharding is being done across this family of Azure services. So they have about 8 different Azure services mentioned here, and I was very interested. I was intrigued by this article because I was hoping that I would learn about how these services are different and how what are the commonalities or differences in their sharding architectures. But that's a bit, more elaborate. So I believe that for me to really learn in depth about each of their sharding architectures, I would need to, dig some, like do a deep dive into each of them and learn more. But again, the reason of sharing this today is um, the idea of this session is more like, if somebody has worked in an area and you have very deep knowledge of something, that is amazing if you can bring that up and share something. But otherwise, it's more like food for thought, right? Have some takeaways, some new things that you learn from this session, and then how you can take it further and, do your own research and maybe come back and share with the group. So let's move on with that. So the agenda, I would request anyone, if you are monitoring chats and if there is something, related to something critical that comes up, let me know.
Sure.
So talking about high level agenda, right? Like I was saying, it's learning about new concepts. I didn't know about this concept of shardlets. So there would be some, I would be talking briefly about these different components of a shard management system. Then in one of the articles by Azure, they talk about the single tenant versus multi-tenant sharding. So some of the new concepts there. And then talking about how the Facebook article actually talks about how hash-based, partitioning has its limitation, and the other approach to sharding, which may be like key-based or basically non-hash based approaches are can be better in some scenarios. So that was interesting to learn, because a lot of times when we think of sharding at high level, it's very easy to think, oh, I'm going to use the hash of my partition key and modulo it with the number of servers. That's the common thing that we hear all the time. But it's interesting to see that perspective, that how in real world they recognize the limitation. And last but not the least, like I said, I would encourage you to think about the last component and overall, actually, the theme of this talk. If you stitch everything here together, think of it as if you're asked to build a shard management system, right? What are the kind of features you would think about? How would you split those features across different modules or different components? So, yeah, any questions anytime, feel free to jump in. So this is a very introductory, like I believe most of us here would be familiar with this concept that anytime the requirements for an application or a database grow, we tend to scale them out, right? And there are two different approaches to scaling. I'll be going a little quick here. So vertical scaling, like it says, basically you're taking a single box and you are adding resources to it, right? Be it memory or CPU or um, basically you're beefing up a single box. But then there is a ceiling to it, right? You can't just keep adding resources to a single box. So that's where horizontal scaling comes in. So beyond a point, horizontal scaling is the way to go. And sharding is one of the common ways to implement horizontal scaling. Um, Now, one of the important things to note here is that when you are using sharding or horizontal scaling, you are actually talking about data which is like structurally should be identical. As an example, if you have, let's say, a table of employees, and you have like X number of records, if you're talking about relational or in general. So each of those, and you're putting, let's say, first 100 rows in first shard and so on. So each of those rows have a identical structure. So that's the idea of horizontal scaling. And vertical scaling, would anybody like to give an example of vertical scaling, like how it differs from horizontal? Apart from, like I said, adding resources, but if I take a database of, let's say, an employee table, so we talked about what would horizontal scaling mean in a database, that you split the rows. What would be an example of vertical scaling? Or actually, I should use a better word for it, but vertical partitioning, let's say. Yeah. Anyone has?
Not
Across
sure.
columns.
Right.
Sorry, I was trying to clarify the horizontal scaling. It may not be necessary that you want to have same kind of columns in all the shards, right? Like this may apply to relational database as such, but
Mhm.
if you are looking at NoSQL database, it could be any keys. I think it's more relevant with respect to the keys than
Right.
anything else.
Sure, sure. Because NoSQL won't. Yeah, that's a good point. As I was speaking up, I had that point in mind that since NoSQL are not really adhering to a very fixed schema, so there may be some, flexibility there, but possibly, yeah, going by the key, I think that might be the case. Um, I agree with that idea. Anyone else has any other things to add on to that?
So if you see the link
below the diagram, it says Azure SQL. So, so this is for a relational database. So for Azure SQL, if you want to scale vertically, you
Uh-huh.
could upgrade the tier. So there are different levels of tiers.
Right.
Or if if the premium tier doesn't meet your needs, you could actually uh, allocate your own elastic pool, which is a like a set of servers,
Sure.
and you can decide like how you want to distribute your
Right.
individual databases like across that elastic pool.
Sure. Right. Yeah, they were talking about this concept of elastic pools and uh, yeah, right.
Yeah.
Yeah, thanks. So yeah, in terms of scaling, you were saying, right, having different tiers and then you are, splitting your data across. I think I kind of took a little bit of segue there, but maybe let's first talk about relational here, right? So if we are talking about when we are adding nodes and we are splitting our database, we took an example of horizontal partitioning. And I think somebody spoke up about vertical partitioning where we are going by the fields or the columns. So you're keeping, let's say, three columns, all the data from all the rows of three columns in one shard, and then other columns in, across different shards. Um, but yeah, so this is more specific to relational because we are talking about a fixed schema. And this diagram itself comes from Azure SQL. So um, yeah.
So, one question here, will each database have one shard or they can have multiple shards?
Yeah, so that's coming up. So that goes back to, I think there are concepts around shardlets, or you can also have multiple, like it comes back to my understanding, it comes back to multi-tenancy, and then you have to ensure that there is isolation. So one database, one shard, basically one server, you have to split it up in terms of one server is holding multiple, can hold multiple shards, right? So each shard I'm looking at is
So,
a single database. Single database.
so by server, you mean one machine or
Yeah, one node. Yeah.
okay, yeah, I just always have confusion about so there is a machine and then in the machine do we have multiple databases and inside those each databases do we have multiple shards?
No,
Is it
no.
like
So
that
I'm
or
no. So I think the idea is uh, a database, a particular subset of database, right, is called like a shard. So this is like if I have in this picture, I am looking at it as these are 5 or n shards of one database. So if I look at it as like 5 different servers as an example, then each server is holding one or like a subset of one database. So shard is like I'm thinking of a, you know, part of a database. So if I'm having, let's say, one server, it can hold uh, multiple shards, which may belong to different databases. Correct me if anybody has a different opinion there. Does that make sense? Like, I don't know who was asking question. Was it Abhishek or?
yeah, okay, I don't know the answer so I don't know.
Yeah,
It
that's
it
my
depends on it depends on how. Again, I'm just trying to correlate from what I see in practical world. It could be. Uh, it is a logical separation that we should think, and then whether to place multiple shard on a same box or on different box is a deployment construct.
Sure,
So
sure.
when you
That I agree.
Mhm.
Yeah. I think he was asking more
Yeah, okay.
terminology, right? That's
No, no,
how, yeah.
no, I mean, no, not the. So I wanted to ask that uh, can a database have multiple shards? So I think his answer is yes, it can have. It depends on you. If you want, you can. I mean, I just wanted to understand that. Uh, so like my understanding is that a machine could have multiple databases, and each database could have multiple shards. shard is just a logical unit. So each one, and now it's up to you. I mean, if you want, that's up to your design, that if you want in your one machine you can keep one database, in one database you can keep one shard. But yeah.
Yeah. Okay. So yeah, I mean, I don't want to confuse. I think we are kind of thinking the similar idea. But let's continue and see if there is a, if there's more discussion around that. So yeah, this and these text here, I just literally pulled from these articles because just to explain the concept and pull snippets from it. So this is basically saying that when you're having a transaction, the way I interpret this is if your transaction is such that it is restricted to a single value of a sharding key, then basically all the data you need for the transaction is local to your database, and that's good. But if it's spread across different shards, then it becomes like, you need to join database that data and all of that. But in general, the best case scenario is if, every transaction in an application can be restricted to a single value. Um, so this was an interesting point here, like how most cloud scale applications use a combination of these two strategies, horizontal scaling and vertical. So when you get new customers, right, you can have horizontal scaling. And one of the simplest ways, I'm not saying the best way, but as an example, you can just have like one shard for every customer, right? And then vertical scaling to basically grow that shard by adding more resources to it. So like the premier tier and, all those different levels. So this is an example of single tenant and multi-tenant. And here, like I was giving this example, right? You're having this sharding based on the tenant ID. So if I get a query where I say, if tenant 2 comes in and they want to retrieve some data, then it's basically, I know which shard to go to. It's a simple mapping there. And the benefits of that is that it provides isolation, and you can have resource scaling at the granularity of the tenant. I wasn't sure what they meant by backup and restorability, but yeah, so this wasn't something that was clear to me, this feature. Maybe they are trying to say that since it provides isolation, so you have your data kind of secure and you can do all these features. But yeah, that was a bit of a, I wasn't sure about this particular point. But in general, that's the concept here. And with multi-tenant, the idea is that when your application manages large number of small tenants, right, then rather than allocating, uh, you know, one shard for complete, like for one tenant, you can actually have multiple tenants, on the same, for the same database, like here they are showing. And we'll come to these ideas. So now, since you have um, one example they talked about is, let's say you have some data, million rows, and some data belongs to certain, is only accessible by certain tenants versus others. So there they talked about row level security and how that can be used to filter which tenant can access which data. So that's one way of, providing isolation in this situation. But in general, these are the two paradigms. And I would expect that I would assume that apart from very specific applications, multi-tenancy is the way to go for many cloud-based applications.
A quick question on the row level security.
Yeah.
Do we have anybody with some experience on that? How does this work? And uh, is this like some configuration in Azure that I have a table and I can set up these rules or something like that?
Yeah, so I would encourage if somebody has experience, but just one thing there in terms of who can access what in the architecture that they talk next. They talk about some, sharding mapping manager, and which takes care of which shard to hit and all of that. But yeah, if somebody has experience working on it, please feel free to share.
So SQL Server supports row-level security. You can define a security policy, um, um, like you can define the criteria and decide like who all have access to those specific rows. If you search like just SQL Server row-level security, you'll see the commands and you can try running them.
Okay.
For the single tenancy, the backup and restore ability basically allows you like the specific tenants to back up their data and then retain with them. So if I have two companies, A and B, and I'm hosting their data on different
Right.
shards, each of them can have their own backups. But if they share the same shard or the same database, then I just can't take a full database backup and share with any of those customers.
Oh, I
So
see.
this is just allowing like it's an add-on. Like with this isolation being specific to a tenant, it's allowing them to take a backup for the entire database and like use them later to restore. So it's providing tenants that ability.
That totally makes sense. Yeah. Yeah. And in this case, it won't be possible because it's shared. So, yeah.
Right. So here there needs to be someone who owns that data and they act as an intermediary to
Right.
share backups.
Right. And basically, you can't even just take the whole backup, right? Because that's not all of your data. So,
Right.
thank you. Any other questions? Great. So, I already learned good stuff here. Okay. So, moving to the next point in the agenda, which was about why hashing, what are the limitations of hashing, right, when it comes to partitioning your data. So in the book, we read about two approaches to sharding. One is key-based and one is hash-based. And this is a very common, idea we have when we have to partition data. But this was, I picked up this snippet from the Facebook blog where they talk about that how this has limitation, because if you have constraints like around locality, right? If you want to place, for example, they gave example of European Union. So hashing cannot, the support there is limited, right? How much you can control where your data is placed if you just go by this pure hashing based approach. That's point number one. The second idea is the data movement, right? If you take this simple approach, then we know that when you add servers or when you take down some servers, this problem of data movement, right, to rebalance your data across the available servers is becomes huge, right? Because you have to move all your data around since it's dependent on this model of servers. So consistent hashing comes as one of the solutions that could alleviate that, because without going into much detail, unless somebody wants to have any questions, but the idea, the consistent hashing saves us from that problem to some extent, because we only need to redistribute a small subset of data. But again, like I said, they highlighted this issue that anything which is based on pure hashing has this locality based, constraints that we have, that becomes a challenge. And what they revert to is that partition data into shards. And I mean, this to me goes back to more like key based, right? If you're not using hashing, then you're using some distribution strategy where you're saying this set of data would belong to this shard and so on. And I'll talk about two approaches that they share, but yeah, so that was the point around why, what are the limitations of hashing. And then there's also this concept about, right, when we are talking about partitioning data, you have definitely improved the throughput of your queries by splitting data, but also for fault tolerance, you would want to support replicas, right? And this Facebook blog talks about how how they look at the different applications within their ecosystem, and they can broadly classify them into three different categories. We'll see it in the coming, discussion, but it's interesting to see how they have classified the, several applications they have into these three broad categories, and then they try to map a sharding architecture based on each of them. But here the takeaway would be the limitation of hashing and then replication along with partitioning that we even saw during the discussion of the book chapter. All right, so from here, moving on to, what are the different components? This is the point where I start thinking about if I were to brainstorm about designing a shard management system, right? What are the components? What are the features I would need? Uh, any questions till this point? Okay. So starting with a bit of terminology here. Um, so like I said, they introduced this concept of shardlet that I wasn't aware of. And what they're saying here is that let's say you have three shards, and within each shard, right, you have this uh, shardlets defined, and shardlet is basically a smallest unit of data that you would need when you're redistributing, when you're doing this reshuffling of data. The granularity, the smallest granularity that you would consider is shardlet. So first you have different servers, then you have basically different shards, and then within each shard also you can have this concept of shardlets, right? So that was new there. And we'll talk about other components, but just very quickly. So when we say sharding, right, there are two things. One is when you're actually writing your data to a database and you have this sharding in place, how do you know which shard to write to, right? Where to route your request. And the second is similarly for reading. When a read request comes in, which shard to route it to. So for that, they talk about two different maps that they maintain. One is global, which contains a mapping of sharding keys and the respective shards, right? And the local shard map, and this is maintained at the high level, right? You maintain a separate database which serves as which holds your, this mapping, global shard map. Now, once you reach the appropriate shard, there you actually have another mapping which maps which maps it further to the shardlets, right, within that shard. Um, yeah. And like I said, so shard map manager is basically which is containing this global shard map. Um, so now we talked about this, how you're like hashing has some limitations. Not to say that it's a total no-go, but what are the alternative schemes? And these are some examples, right? So they give example about list mapping and range mapping. And I think these are some of the concepts we even covered during the chapter. So yeah, this is, I guess, pretty intuitive here. So list mapping is just your listing, right? So this is, for example, a combination. This is actually just the list mapping. And this is, yeah, range mapping. Um, Pretty simple one here. Yeah, so this is now in this article, Azure articles, they also give some code snippets, which was interesting. That when we talk about the shard map manager, right, which is containing mappings of your, and like I said, the way they talk about this is it's a database on its own, and within it can also be horizontally, like scaled, right? But think of it like as one entity which contains your mappings. So the first thing you would do if you have such a system is to get hold of this, shard map manager. And once you get hold of this, then you need to capture the mapping data structure that it holds, which will give you access to the different shards, right? So this is a code snippet that they provide for shard map manager. Um, and they talk about how, now I am not very familiar, I haven't worked on these things, but one thing that they talked about here is each application domain can only have one shard manager. So, and that is what we see here, that first you try to get access to the shard map manager. If it exists, then you just, kind of refer to that. Only if it doesn't exist, then you create one. But I am not very sure about their idea about this, application domain to shard map manager. I could see how they are relating it with the code, but I don't have much insights about that application domain and this map manager. If anyone wants to speak to that, okay. Um, yeah, so in that case, we'll continue. And if anyone wants to dig into it, yeah, sure. And one of the interesting things I found here that they mentioned was, it was very like segue to this. It's not related very deeply to this discussion on sharding. That this idea, right? Shard, map, manager, factory, right? So they are, in terms of design patterns, they talked about this factory design pattern that they use to basically, create a map manager. And then I got curious about what this factory design pattern is, and we can take it at the end of the discussion, just not to, dilute that whole focus there. But so this is one thing. And then they talk about that once you have uh, reference to your map manager, then how do you basically create or access the shard map, right? So I thought, I mean, in general, this is an interesting glimpse. I mean, this is a good insight into, we have other sessions, we have other channels which talk about system design. And if a question around partitioning comes up, and if somebody really wants to go deep into it, it's an interesting insight into how, you think of the code implementation and the different components. Uh,
I wanted to add a few things here if
yeah,
uh, so like this library looks pretty complicated, but in essence what it is trying to do is getting a connection information, populates a connection information based on the key that you have provided, right? And in essence it maintains a lookup where for that key which logical shard the data belongs to and what is the connection string that's
okay.
point to that logical
Yeah,
shard.
yeah, I
So
think
if
that's this one. Yeah.
yeah, and and if somebody doesn't want to use this layer, I've seen examples where instead of using this specific API, teams have built a layer where they give they give the key name and the system behind gives the actual machine where that key exists. So that's a simplification that I
Right.
just thought to add it because there's too much code on on
Yeah,
this.
right. Yeah, thanks for actually bringing and abstracting like the details, because it's hard to read through everything here. But I agree, like one way is like you suggested, you give a key and you get, where is that, shard located, like the machine ID or something. But I think another approach that they have highlighted is here, right? You Well, it can be actually similar, but here they are returning a reference to that whole map. And I think as the third step would be what you are suggesting, right? That once you have hold of the map and you say the key, then you can get the whatever the mapped shard ID. Is that,
Yep.
does that
Yeah,
make sense?
yes. I think in the simplistic form that I see is like you need a lookup which has the range of keys that
Right.
a specific database or physical database stores and some way of querying that information.
Correct.
And
Right. Yeah. Agree. Okay. So yeah, that was that. And then further, so we talked about first getting a hold of map manager, then we got hold of the map, right, which holds those mappings, and then there is this other APIs where you can actually do all these specifics, create shard, delete shard, and all that. And this mapping thing that we talked about, that also has, they have separate APIs for it, right? To manage all these different operations. The way I interpret, like I kind of try to summarize in my mind what are the kind of high level things I'm pulling from it, is like somebody was suggesting here, right? High level, what would be my flow? What would be the data structures I need? This idea of using factory design pattern was interesting. And then further, how can I further modularize my design, right? When I'm talking about different mappings or these different operations. So for me, that was one of the summaries of reading through this. And then they talk about this idea where I am not sure what's the key design rationale for it, but they talk about how these mappings here, like when you say delete mapping or something, it's not like that it only invalidates the references to your code. It doesn't just delete, suddenly the objects. So it says like mappings are immutable, and this is an example. So if you want to delete the mapping for this key, then that's kind of an example of an API that you support. All right. So now moving on to the Facebook sharding architecture. So let me actually bring up their first few. I thought of just referring to their blog here, um, but let me first come, or maybe let me just pull their blog. Can you all see the blog page? I just want to make sure I'm sharing the right screen.
Yep. Yep.
Okay. So yeah, I talked about the motivation, right? Why they came up with this generic infrastructure, because they have this family of Facebook services, Instagram and Messenger and all of that. And all of these teams, they noticed that they had their own sharding architecture in place, which is problematic from multiple angles, right? First of all, there is like redundancy going on. Each of them is just having their own code. And the second thing is, if there is some limitation, some feature that is missing in one of the team's architecture, like the sharding architecture, it's good if they could benefit from, if that feature is present in the way other team implemented architecture. So the idea was, can't we bring the goodness of all these different, implementations together across a generic platform, and also eliminate all this, silos, so to speak. So that is one. And the other idea was that they had this very interesting idea of, do they have, yeah. So we'll talk about this diagram later, but the idea is this configuration specification. So we talked about how sharding is also tied to replication. So if you want to say, I want to have 3 replicas or 6 replicas for, my database, and so how, and then um, yeah, so that kind of specification or the reliability guarantees, right? Consistency guarantees that can vary from different applications that Facebook supports. So one of the examples they gave here was a simple, one second. There can be an application which is very simple, like maintaining some counter. Yeah, so here they say, right, how different applications complexity is different. So there can be a simple counter service application which only needs, few servers, versus a global storage, service which needs thousands. So their scaling needs can be different and all of that. So this generic sharding architecture that they came up with, it allows an application to specify its, requirements, and via this configuration idea, and then basically the same architecture can be tuned to that. So that was another key feature of the architecture. And then they talk about, so yeah, these different applications it supports. And this is what I was talking about, that they basically classified their applications and their sharding requirements across three types: primary, secondary, and a combination. So the primary is basically each shard has a single replica. So uh, yeah, I mean, and then they give an example of stream processing, a sample application which uses this kind of paradigm. Similarly, secondaries are the ones which are mainly used for like read-only like loads, and what they say is machine learning inference, right? Which basically downloads the trained models from remote storage and so on. So here, basically, each shard has multiple replicas and each of them have equal roles. Primary, secondary is like some of us can guess here. You have a primary, replica, and then secondary. So primary will serve writes, and the secondary can serve reads. So this is, yeah. And then they give an example of this database, which is a global key value store, and it requires this. Um, so that's that. And now coming to, and again, like they talked about similar concepts that we looked at Azure, like all these operations, right? They have these APIs, add, shard, delete, and so on. So this is all good. This is the intent-based specification I was saying about configuration. Like you can specify what's the replication requirements for your application, right? How robust do you want this failure detection? So there are different options that they provide, and each application can go ahead and specify what their requirements are. Um, so yeah, I mean, each of them like shard scaling, all of them are talking about that concept. Um, so this is another idea they talk about, that how their architecture automatically manages, like if you have, let's say, 4 containers and you have these shards deployed, and if you are saying that at a given point of time, I want 3, replicas of my database to be available. And if you specify some operation on one container, like maintenance operation on one container, that's fine because you still have 3 available. But if you later on specify, okay, I want some update on containers 1 to 3, then it's not going to just launch it right away because it violates your availability requirements, and it will do it one by one. Um, yeah, I think the high level takeaway, the way I looked at this whole discussion was, uh, there is fine tuning that can be done for each application. So that's supported in this architecture. Now coming to this one, so they talk about how they are looking at it in a layered approach. So these are the different applications, right, that can be supported by within Facebook, and how the shard manager takes care of it. So they look at it in a layered manner. So like the names are pretty intuitive here. So the bottommost layer is like hardware resources, and you can actually say that, let's say, this organization or this sub team is allowed to get X percentage of my hardware resources I have. So you can make all those constraints in place. You can put all those constraints in place here. Then there is this container management. It's interesting, like they suddenly jumped into this idea of containers. I don't know, it seems to me like that's how they are just implementing overall, like that's a common thing that they're using in their architecture. But yeah, here they talk about that uh, whatever resources you get from the underlying system, then you allocate it to applications in the form of containers. So at this layer you create containers, and each container can get access to certain resources in the system. And then shard manager basically allocate shard within the containers. I mean, it's kind of a container based sharding, uh, I mean, container supported sharding approach. Uh, so that's that. And now coming to the specific, like when I was saying, if we have to think of shard management system, right? Before getting into this diagram, if we talk about what are the features that should be supported by the management system, what do you think? What are the some features that comes to your mind if you have to design one? Some of these are right here, but like what are the components, not just breaking it into components, but what are the features you would think that your architecture would need? Anyone?
So, okay, yeah, I can talk about a few things which comes to my mind.
Sure.
So, I think one thing would be that what machines those shards are. So, the IP address of those servers,
Right.
and then so that is one where they're keeping the configuration, and also the machines can go down. So
Yeah.
then they would need to rebalance and put
Right.
other nodes. And so again, that configuration needs to be updated, and someone needs to know whether those machines are available or not. So that's why they have this heartbeat kind of thing,
Yeah. Yeah.
which will tell whether it's available.
Sure. Yeah. Yeah, I mean, those were like spot on. Other things, like I guess one of the things we can think on the same direction, like the last point you said about this monitoring the health of those, systems is like even the traffic fluctuation, right? If some of the shards become hotspots, or if you need to increase the replicas, or all these requirements, then I guess handling all those uh, resource fluctuations, or handling managing the hotspots. Yeah,
Mhm.
right.
How
So,
about auto rescaling? For example, there is a tenant ID based sharding, right? And if
right,
that shard goes above certain limitation,
exactly. Yeah, so you would need to add maybe, further, like shard it further, right? Split it and add nodes. I guess that's more like the resource scaling and like the load balancing, I think what Abhishek was alluding to in a similar space. Is that the same thing you're referring to?
yeah, it is more or less kind of a load balancing, but I was maybe talking in terms of storage as well. Uh, that is, for example, I'm storing data for one particular tenant under one database, one shard, which
Right,
is based on the tenant ID, and there is a physical limitation to that,
exactly.
one shard and one machine. So
Right.
there would be some overflow concept, or maybe we don't allow that
Sure,
limit to
sure.
go up, right? So some mechanisms around the storage
Yeah,
load.
definitely. Like we don't want to create a skew in the data distribution, right? That one is just growing and you want to redistribute, and some mechanism to handle that. Sure.
Yeah,
So
yeah.
yeah, so see, yeah, I think you all captured, summarized all those points. That was like covered all those points there.
So
So
what was the service discovery system over here?
yeah, so this one I looked at it as more like the map manager, like what we saw in the earlier one, but we can bring it up. So I think it's more like like which, when a request comes in, like which shard should I go to, right? That kind of mapping information. Uh,
I thought Zookeeper was for that. Uh,
no,
Zookeeper has
Zookeeper,
that map.
I think, let me just keep visit.
So instead of clients discovering directly via Zookeeper, they try to push it to clients itself. The routing strategies. So the client needs to know which shard it needs to go, it is already pre-populated. push mechanism, I would say, instead of pull.
Okay.
Okay.
Oh, that's where you're talking about how this thing is there. But I think the question I'm having is, so I see that what is scheduler doing, right? It's taking care of all that load balancing stuff. And then this says like shard allocation info, right? So this is where I was thinking like all that mapping information is here. And then to what you were just saying a minute ago about that push versus pull model, maybe that's this part here, right?
Some of the implementation that I have seen, basically the client library is the intelligent driver. It, like let's say in this case, one of the shard for some reason goes bad, and the system will know, or the shard manager's scheduler equivalent component will know the shard is bad. Now
Right.
you need to propagate that information back to the client so that they don't
Right.
route request to the bad node.
Makes sense.
Uh,
True.
so
So
for like
basically,
depends on the client implementation, how whether the client is polling this discovery service every X
yeah.
seconds.
Hmm. Sure,
So
sure.
I don't know what, like I have not looked into this architecture, but if I were
Maybe
to,
logically it makes sense, right? Like, so what if I'm reading this right? So based on what you're saying, first of all, we can provide all this configuration, and the scheduler will take care of, allocating the right number of shards and also coordinating with Zookeeper to keep track of if any server goes down and all of that stuff. And then based on all of that information, that is passed down to this system, right? Pushes it to the client library, right? And then the client can, take care of that routing stuff. Um, that's how I'm interpreting like some of the things that you mentioned. Does that make sense, or like did I interpret it right?
So one of the other thing would be if clients are directly reading from Zookeeper, I mean, if they want to switch to another database or something, it would be difficult. I mean, you are directly exporting it as Zookeeper itself. So if you want to change it to another DB, it would become, it would be difficult to make this transition. And yeah, and also it would keep unique since clients are directly, if they have to read from Zookeeper, this needs to be highly available as well.
Right, right. That's true. Yeah. I mean, it comes
yes,
to life now.
some of the
But with this
implementation.
model, yeah,
Go ahead, Abhishek.
I was saying that the main purpose was Zookeeper was that it's the source of knowledge of truth and it will take care of scaling and all those things, right? If we have now two source of truth, then how do we keep them in sync? Because the point is that so in Zookeeper we might the, which is directly talking to containers, we might see that some node is down and it might know that, but while it was propagating it all the way to the service discovery system, they are still routing to those old nodes, and
Yeah, I mean,
so
that
your
is a very,
service
yeah,
is
that,
going to that wrong.
right,
So
right.
that's why I always thought that like Zookeeper is kept as the source of truth. And like so my understanding of the service discovery system. So what the service discovery system kind of thing does is that your machines are hosting multiple services. So these service discovery system are running on each machines, and they will tell you that on what machine what service is running, so that
Oh,
you know at particular time what machine is hosting what services. Uh, so I mean, yeah, I could not understand this diagram.
So, Abhishek, just to add to your other point of failure, my understanding is if the most of the intelligence is built in the client library. Let's say If the client library tries to write to a specific shard, and if there is a failure, you will write code in a way that if you see a failure which says that shard is unavailable, go talk to the service discovery system to find which is the most latest replica or latest shard or latest machine which is hosting this shard. In most implementation, the client, the mapping will have multiple like multiple servers or multiple targets for the same shard, like primary, secondary, and other replicas. So either the intelligence is built in the routing library to do the fetch from the discovery service, or there is a precedence in the in the routing library where if the primary fails, go to the second replica or third replica or some sort of backup strategy there. It also depends on the implementation. I don't know the Facebook specific implementation. I've not read that, but I've heard, I've seen people implementing that kind of strategy where it's more on the client library, the DAL layer, or which has some more additional intelligence built into it based on the error code that they see when they try to write to a shard.
Mm-hmm. Okay. Yeah.
Yeah, here they give very high level information, but I think the points you all are mentioning is adding to that. So that's great. Yeah, here they just talk about the manager scheduler, which takes care of all the server join or failure options. And then, yeah, this is pretty high level that way. Okay, so yeah, so that was that. And then they talk about the limitations, like the upcoming challenges that that are still pending, like that they hope to accomplish in the coming versions. And one of the things is about just the growing, right? Like supporting tens of millions of shards per application. And they talk about this idea of partitioning the application into independent partitions. That is a little vague to me. I mean, I'm not very clear on that point, but does anybody has any insights on that?
Uh, Not specifically for Facebook, but
Yeah.
the real world example could be like, let's say you are storing population or the population data of a country, and then you don't if you put if you partition it based on states,
Mhm.
let's say 50 states in US, then if one of the partition goes down, you are basically losing the entire
Right.
state's data. So one of the other thinking on much of the larger scale systems is, could you reduce the partition size to a very small size so that
Oh,
if you want to move that partition for whatever reason to a different location, the actual
mhm.
size is smaller to for it to move or easily movable,
Right.
right?
Like the
Instead of
data
moving
movement
the
is less. Yeah. Okay.
I've seen that kind of models talked about. If you look at big data or big table, design, like similar to Facebook, the sort manager, there is a concept on big tables, and you look at where they talk about partitioning at a lower granularity.
Okay.
And in that case, the main motivation is the redundancy, right? Like if you want to move the partition from one
Right.
physical setup machine to other, it will be easier, something on those
Rebalancing that.
lines.
Yeah. Yeah. Great. Thank you. And the other thing they talk about is, like the components that they shared. How can we make it more like to support more complex applications by having more modular or pluggable modules? And the third thing was interesting that, if you have a small, simple application, is this whole, architecture, is it too heavyweight, right? How can we simplify the experience for small scale, small applications? Uh, so yeah, so that was pretty much in general the topics I had. Now, talking about in general this article about Azure, different services, when I went through it, I, like I said, I believe we need to do a deep dive on each of them if we really want to understand the sharding architectures. They did talk about the concept of shardlets and how, for example, the requirements of event hubs, right, which are more for supporting data streaming, is very different from in general Cosmos DB, for example, which is a NoSQL database. So I kind of captured those kind of things from this article and their general shardlets concept, shard map manager. But I would say if somebody is interested, it has links and you can do a deep dive. But this was a good list to look at. All right, so I think we are kind of on time here. So for me, these were the major lessons that I picked up, and I have to say that thank you so much for jumping in, and I learned a lot of things that I wasn't clear about. So these were some of the things I kind of had in mind when I was preparing this, but I'm sure I can say that I learned more from this discussion. Um, so yeah, this is what I had. Anyone wants to add anything? Any comments, feedback? So maybe I can stop recording in that case and